Good morning, everyone. Now we're moving on to our next lesson. Now, when you go onto the page, you click on number, you click on fractions, and you go on to year 4, introducing equivalent fractions. So we're moving on to a new topic now, and we're moving on to fractions. You have done this before in class, so hopefully you should be familiar. If you're not sure with what's going on, click on the PowerPoint and go through it again. Watch my video. If it's still unclear, just drop an email or comment on the blog, and one of us teachers will come and help you out. So, introducing fractions, it's introducing equivalent fractions. So think about the word equivalent. So equal means the same, so it's having the same value. So objectives are recognizing and showing families of equivalent fractions and simplifying fractions. So counting in fractions, finding equivalent fractions to a quarter, to a third. You've got the fraction wall, you've got why equivalent fractions the same, fraction diagrams, simplifying fractions by repeated division, and 5 questions at the end. So starting off, since a fraction is a number, we can place it on the top, on the number line. So we've got quarter, 2/3, you've got loads there, 5/12, 1/12, 11/12. Placing fractions on number line makes it easy to count them both forward and back. For example, fifths, we've got 0, 1/5, 2/5, 3/5, 4/5, and 5/5. So 5/5 are the same as a whole. 1/5, 2/5, 3/5, 4/5, 5/5, which is the same as a whole. You can count backwards. 5/5, 4/5, 3/5, 2/5, 1/5, and 0. Where you've got nothing. The number line can be marked to show any fraction. So we've got 0 up to 1, so up to 1 whole, and we've got it in 12ths. So 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, and 12/12. This line can be used to count forwards and backwards in 12ths. Which is quicker, counting to 1 in 5ths or 12ths? Which one will be quicker, counting to 1 in 10ths or 11ths? Remember, the bigger the denominator, the more the pieces of the fraction, so the more pieces that we have. So if I had 1 whole and I had it in half, and I had another whole and I had it cut in quarters, so imagine if I had 2 cakes, 1 cut in half and 1 cut in quarters. Which one will be quicker to count? Which one will have the most pieces? So the bigger the denominator, the more pieces you have. Equivalent fractions are fractions that look different but show the same amount. So equivalent fractions, there we go. So they all look different, but they're showing the same amount. So they're all showing half. So you can see that 2/4 is equal to a half, 3/6 is equal to a half, 4/8 is equal to a half. Now we've got these fractions. Shade in half of each shape and write the equivalent fraction. Now, looking carefully at the shapes, what you've got to look at is the denominator and the numerator. So 2 and 1. So 1 is half of 2. So if I've got 4, half of that is 2. If I've got 6, half of that is 3. If I've got 8, half of that is 4. If I've got 10, half of that is 5. So here I'm going to colour in 2. Here I'm going to colour in 3. Here I'm going to colour in 4. And here I'm going to colour in 5. Okay? Now, half of 16 is 8. Half of 24 is 12. Half of 100 is 50. They're all showing half, but as you can see, the numerator and denominator has changed. Okay, this is saying it's not correct because I haven't coloured in the pictures, okay? So the fractions are correct. Shade in a quarter of each. Now, if a half is this, a quarter is 1, okay? So 1 out of 4 is a quarter. So I'm dividing it by 4 this time. 2, because I know 2 times 4 is 8. How many 4s go into 12? 3. How many 4s in 16? 4. So 12 was half, I'm going to half it again, and it's 6. How many 4s go into 125? Okay? Then you'd colour them in. 6 here. 4 there. Now, remember, when you're doing this, you have to be careful that you actually counted them properly as well. So 3, 4, 5, 6, 7, 8, 9, 10. This will need another row. So that's going to be 20 when I get to the end. 21, 22, 23, 24, and 25. There we go. Okay. Next one, shade in a third. So this time we're shading in 1 out of 3. So it's 2 out of 6. So how many 3's go into 9? How many 3's in 12? How many 3's in 15? And how many 3's in 24? Okay. And then you shade them in. So we've got a fraction wall here. And it shows you which fractions are equal to one another. So it might look confusing at first, but all those fractions are equivalent to a half. So we've got 1, 2, 3, 4, 5, 6 twelfths. You've got 1, 2, 3, 4, 5 tenths. You've got 4 eighths, and you've got 2 quarters that are equal to a half. So fraction rule always helps. So I need to find 3 quarters now. So 3 quarters is there. The ones equivalent to are here, eighths. So I've got 1, 2, 3, 4, 5, 6 eighths that are equivalent. So they're the same value. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. Okay, that's how we use the fraction rule to help me. These fractions are really the same, that means they're equal, okay? Because when you multiply or divide both the numerator and denominator by the same number, the value stays the same. So, 1/3 times by 2, I'd get 2 6. Times by 2 again, I get 4 twelfths. So in the pictures, it's the same thing. So I've got 1/3, 2 6, 4 twelfths. If you cut a pie to twice as many pieces, you need to eat twice as many to get the same amount of pie. Here's a catchy little rule to remember this by. Change the bottom using multiply, divide, and the same to the top must be applied. But we always use in school, whatever you do to the bottom, you need to do to the top. Whatever you do to the top, you need to do to the bottom. Okay? You've just got to remember that. Whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. This might get a little confusing, so just follow the arrows. 1 times 2 is 2. 2 times 2 is 4. Next arrow, multiplying a half by 3. So 1 times 3 is 3. 2 times 3 is 6. 1 times 4 is 4. 2 times 4 is 8. Okay, that's how I've done it. Simplifying a fraction means writing it using smaller numbers or for the numerator and denominator. So the smaller the numerator and denominator, the better. So instead of 8/16, I can write 1/2. Okay. So remember, a factor is a number that can be divided into another number without a remainder. If the numerator and denominator are both even numbers, we can start with a factor 2. So let's simplify the fraction 6 eighths. So the even numbers I can divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 3 quarters. Now 3 and 4, I can't divide them by anything else. So they can't be divided by the same number. So that means that's in its simplest form. 24 over 36. We can divide it by 2, but we can also look at 24 and 36 and see what other times tables they're in. For example, the eighths. Now we don't have 36 in the eighths, so can't be that. What about our sixes? So we go through the numbers. Divided by 2, you got 12 and 18. I can divide them by 6 now. Because look, what we've done is divided by 2, divided by 2, divided by 3. So that becomes a long process to get to 2/3. You can also find a different number that would actually fit into them. So here we've used repeated division, but you can also use a different multiple. For example, if I did 24 divided by 6, how many 6's would go into that? 36 divided by 6, how many 6's would go into that? And then you can simplify it again. Or you can just think about the multiple. For example, both of these numbers are multiples of the 12 times tables. So the previous lesson we've done on multiples will help you with this because you'll be able to spot them. So 24 and 36 are multiples of 12. If I did 24 divided by 12, it would be 2. If I did 36 divided by 12, it will be 3. So there you get your 2/3. Now, dividing by 2, here we need to figure out what dividing by. Here you divide and divide it again. So 18 divided by 2 is 9. 46 divided by 2 is 23. Let's divide it by 5, because I know both of them are in the 5 times tables. So 5 divided by 5 is 1. 10 divided by 5 is 5. I'm going to leave the rest to you. Hopefully this helps. Just remember, whatever you do to the top, you need to do to the bottom. Whatever you do to the bottom, you need to do to the top. Use the multiples lesson that we did to help you figure out what number you're dividing by, okay? For example, 21 and 42. Yes, I can divide them by 3, or I can just divide them by 7, because I know 21 and 42 are multiples of the 7 times tables. 7 times 3 is 21, and 42 divided by 7 is 6. So both of them are in the 7 times tables. I can jump straight to that rather than dividing and dividing again. All the best, guys, and take care.